Subtracting fractions. Subtracting fractions is pretty much the same as adding fractions. We still need to find common denominators. So we'll go ahead and get started. This first example we have 5/8 minus 1/8. The denominators are the same. That means that's going to be our denominator in the final answer. That's a terrible 8. Okay, and now we can just do the operation, the subtraction with the 5 and the 1. So 5 minus 1 is 4. Always remember, we can't say this is our final answer until we go through the two checklist thing over here. Is this fraction proper? Yeah, it is. It's proper. The numerator is smaller than the denominator. Can't say that. So, denominator. All right, got it. So yeah, the top one is smaller than the bottom one, and that means that it's proper. Is this fraction in its lowest terms? No, it's not. What that means is that we can find a number, the same number, that we can use the same number to divide both the 4 and the 8. And that number is going to be 4. Yes, I'm sure some of you were thinking, I can cut both those by 2. And you're right, but you would have to do it again and again until you get to the answer. So it's better to pick the larger number while you're reducing. Try to pick the larger factor while you're reducing. But anyway, 4 divided by 4 is 1. 8 divided by 4 is 2. 1/2 is the lowest term of this fraction 4/8. So that's our lowest term. Okay, so that's essentially it. That's basically the bottom line concept of what subtracting fractions is all about. You just need a common denominator. So let's go ahead and do one where the denominators are not the same. And I think you all can imagine that most problems in math, they don't usually make them all nice and easy like that with the same common denominator right off the bat, right? So I know they'd like to make us work more. So let's do this one. I left the top one the same. I just changed the bottom one. So now we have 5/8 minus 1/3. Okay, so we need to find a common denominator. How do we do that? I think I've shown you once before, but I'll do it again, at least briefly. In order to find a common denominator, you want to find the multiples of each number. You want to take the multiples, so 3, 6, 9, 12, and then you do the same with 8, 16, 24, 32. And you do that, you take both number sequences as far out as you can until you see a common one between the two of them. I think I'm going to run out of room on your screen, so I'm just going to kind of skip ahead here. 3, 6, 9, 12, and if I take it out far enough, I'll get to 24. Okay? And if I do 8, do the same thing with 8, I got 8, 16, 24. It gets there a little bit quicker, being that they're bigger numbers. But 24 will be the common denominator. Again, practice your times tables. That's where that really comes from. The idea is to be able to do that in your head, okay? But if you can't, you can always do it by hand until you get there. All right, so we have 24 as our new common denominator, our lowest common denominator. And I like to use my little boxes. Okay, so 3 times something is going to equal 24. I need to put that something 2 times in the box. So it's 3 times 8 gives me 24. And I put it 2 times so that I can keep my numbers organized. I'm cataloging the factor by how many times the fraction is getting bigger. So anyway, 1 times 8, 8. Do the same thing here. 8 times 24 is 20. 8 times 24 is 24. No. 8 times 3 is 24. 5 times 3 is 15. Okay. We have our lowest common denominator. I can put my denominator here in my answer. And now I just do the operation with the 15 and the 8. 15 minus 8 is 7. Okay? And again, is it proper? Yes, it's proper. 7 is smaller than 24, or the numerator is smaller than the denominator. And is it in its lowest terms? It is in its lowest terms. 7 is what's called a prime number, and prime numbers are basically numbers that can only be divided by themselves. And 1, but dividing 7 by 1, you end up with 7, so you're ending up with the same thing, so why'd you do the division in the first place? So for me, it can only be divided by 7. And 24 cannot be divided by 7 evenly. So this is the lowest term of this fraction. So we can put our little check mark in both of those, okay? So that's like the next step. We did the easy one. This is a slightly step more difficult, a little bit in that direction anyway, a little bit harder. So now I'm going to throw the problem where most students really get hung up when it comes to subtracting fractions. So I'm just going to erase all this stuff here that you guys already know. 24 was the common denominator. Okay. So last time I had the 1/3 on the bottom. Now I'm just putting it to the top, and I'm going to put the 5/8 on the bottom. On top of that, I'm going to add a couple of whole numbers. This is going to be 5, 5 and 1/3, and this one will be, let's say, 2 and 5/8. And let's subtract them. Let's try to subtract them. We have 8 and 3. Those are the same denominators we had in the last problem. So we already know that the lowest common denominator is going to be 24. So I'll go ahead and do that. And I need to give myself a little bit of room. Hold on here. Let's say here. Okay. And I'm going to take it to the point where it gets a little bit weird, a little bit freaky, or a little bit difficult. And so I'm just kind of skipping all this explanation on this stuff. It was the same from the last one. This is where we're at. Can you guys see that 5? Is that 5 okay? This is where the problem gets difficult, because we have our common denominator. It's 24. But we can't do the subtraction. At least not the way it is. We can't take 15 away from 8. There's just not enough in 8 to be able to take 15 away from it. And I have students that still, they're a little stubborn, and they're just like, well, I'm going to take 15 minus 8 instead of 8 minus 15, and they put 7, and they think they got it right. But no, you can't do that. You can't go up in the subtraction. You got to go subtracting down, at least in this case. So we can't take 15 away from 8. We can't do 8 minus 15. So what do we do? There's a couple of ways to do it. I'm going to show you the way I teach my students, and that is we borrow a whole number. We take 1 away from the 5. Okay, we just take 1 away from the 5. And there's 4 left. And this 1 that I borrowed, I'm going to put right here next to the fraction. Keep in mind, I'm not doing this. I'm not going to say it's 18. Okay, because yeah, 18 minus 15, you could do that, but it doesn't work that way when we're doing this kind of problem, okay? Don't put the 1 on next to the numerator, like so that it would turn into, in this example, like 18. Instead, we're making a mixed number. The way this one was 5 and 1/3, this one is 1 and 8/24. Okay, it's just a whole number and a fraction. It's a mixed number. Next step. That wasn't too hard, right? All we did was borrow 1 and put the 1 over there as a whole number next to the fraction to make it a mixed fraction. Next step is to convert this mixed number into an improper fraction. Okay, and so the point means multiplication, and obviously the little thing means addition, right? Little cross. So 24 times 1 is 24, plus 8 is 32. I had to think about it. Wow. Okay, so now we're saying 1 and 8/24 is the same as 32/24. It's just in the improper form. Okay. And then I'll just go ahead and rewrite the 15/24 over here. We have our common denominator. We already have that here in our answer area. Now I can do my subtraction. Now there's enough in that numerator to take 15 away from it. So 32 minus 15 is 17. And I don't have 5 anymore. I already borrowed that one to do the subtraction. But I still have 4. So 4 minus 2 is 2. Is the fraction proper? Okay. The whole number isn't part of the fraction. Okay, it's part of the mixed number. But when we're talking about proper and lowest terms, we're looking at the fraction. Definitely just the fraction. 17/24 is a proper fraction, and it is in its lowest term. 17 is a prime number. So anyway. You can put our little check marks there. Okay. So that's, in my opinion, this is probably one of the hardest subtraction problems because it has a couple of steps that are outside the ordinary, I guess, a little bit. In my opinion, I think multiplication, division, and addition of fractions is easier than this particular kind of subtraction problem because it is a little bit more involved, as you can see. I'm going to show you one more, and I'll probably do it twice just to clarify my explanation. But I'll show you one other one that some students have trouble with. You got to bear with me. My orange, for some reason, doesn't erase as well as my blue. But anyway. Okay. So the other problem that sometimes students get hung up on is this one. One that looks something like this. 10 minus 1/7, or a whole number, or a fraction taken away from a whole number. How do you do that? I mean, there's a couple of ways to do it, but this is how I teach my students, and that is to borrow 1 from the whole number, from the 10. We'll leave the 9, right? There's still 9 there. It's not the best looking 9, but it's a 9, I promise. And now I have this whole number floating in the air. I need to represent this whole number like a fraction. And to do that, there's a number of ways to do that, actually. I'll show you. I can put 1 over 1. Remember that fractions are divisions, right? You know, fraction is part of a whole or less than 1. Fractions are divisions, and fractions have 3 forms: fraction, decimal, and percent. But it's a division, so 1 divided by 1 is 1. 2 divided by 2 is 1. 5 divided by 5 is 1. And then later on, so I guess you guys are seeing the pattern here. Any number divided by itself is 1. And later on in algebra, you might see something, x divided by x, where x is an unknown number. But I don't care if I don't know what the number is. What I do know is that if I take that unknown number and I divide it by itself, it's got to equal 1. Okay? And I didn't put that it equals 1. It's going to equal 1. So okay, I have options here. I have this whole number that I borrowed, and I have this whole number floating in the air. I'm going to pick a fraction that will make my work easier. Because when I subtract fractions, what do I need? I need common denominators. So this is what I would do. I would pick 7/7. Why did I pick 7? Because my fraction has a 7 in the denominator, and I need common denominators to do the subtraction. So anyway, now we have a common denominator in both fractions. And 7 minus 1 is 6. And I'll just bring down the 9 that was left over. And that's it. Of course, 6/7 proper? Yes. Lowest terms? Yes. So check, check. Okay? And like I said, I think I'll just do a quick one more time just so you guys can see this. Because I was talking a lot. Maybe you guys were listening to me and not looking at what I was doing. Okay, so let's do, I don't know, let's see, 15 minus 3/16. Okay. Same process. I'm just going to borrow 1 from the whole number. There's 15 up here I can take from, so I'm going to take 1 and leave 14 behind. And I can represent my fraction like any number divided by itself. So I'm going to pick the denominator that's right here so I can make my work easier for myself. 16/16. That's 1. 16 divided by 16 is 1. 14 and 1 is still 15. I'm not changing anything. I'm just changing the way it looks. Okay. All right, so we have our common denominator, and 16 minus 3 is 13. 14 minus nothing there, so we just bring the 14 down. Okay? And always, 13/16 is proper, and it is in its lowest terms. So good luck.